Use the graph of the function to determine the intervals for which the function is continuous. Use interval notation. When determining where a function is continuous, it's often helpful to begin by determining where the function is discontinuous. We should be able to recognize the graph is the graph of a rational function, where notice we have two breaks in the graph. We have a break at x equals -2 and x equals +3, and at these breaks, we have vertical asymptotes. We have a vertical asymptote at x equals -2, where the graph approaches this vertical line but never crosses it. We also have a vertical asymptote at x equals 3. Again, the graph approaches this vertical line but never crosses it. There are no other holes or breaks in the graph, and the graph continues left and right indefinitely. Recall along the x-axis, toward the right we approach positive infinity, to the left we approach negative infinity. And now let's give the intervals for which the function is continuous using interval notation. On the left we have the open interval from negative infinity to -2. -2 is not in the interval. This indicates we have a rounded parenthesis and negative infinity, comma, -2 with a rounded parenthesis. Recall we use a square bracket when the endpoint is included, and we always use a rounded parenthesis for positive infinity as well as negative infinity. The next interval is the open interval from -2 to +3. We say open interval because the endpoints are not included. If they were included, we would say a closed interval. Going back to our intervals, we have union, and then again the open interval from -2 to 3, so -2, comma 3 using parentheses, and then union for the interval on the right, we have the open interval from 3 to infinity. These are the intervals for which the given function is continuous. I hope you found this helpful.